Another really important concept for physicists is conservation of energy. Basically what it means is energy cannot be created or destroyed. However, it can be converted from one form to another. Hence, all energy in all its form has to be conserved. So you can't have potential energy without doing some work, or you can't have potential energy being converted from electrical energy or something like that. Energy cannot be created or it cannot be destroyed. So as an example, let's do this. A rock of mass m is dropped from a tall building of height h. What is the kinetic energy at the top and at the bottom of the building? And find the speed of the rock just before it hits the ground. Now, this is a very interesting problem. Let's talk about this. So in this problem, what they're saying is that there is a rock at the top of a building and it's being dropped down to the floor, right? And it's asking us, what is the kinetic energy at the top? So since it is being dropped, that word is very important. It means it is at rest at the top. So since it is being dropped, right? So that means its kinetic energy at the top is going to be zero because it's not moving. The kinetic energy is due to the motion of an object. However, its potential energy at this point will be maximum, mgh, if this is the height that it's being dropped at, okay? At the bottom, its kinetic energy will be 1/2 mv squared, where v is the velocity just before impact. And its potential energy is going to be 0. Okay? So that's the answer to part A. Kinetic energy at the top is 0. Kinetic energy at the bottom is 1/2 mv squared. Now the next part, it asks us find the speed of the rock just before it reaches the ground. Now in this case, we have to use conservation of energy. Conservation of energy implies delta E cannot be different. So the change in energy cannot be different. What that means is kinetic energy plus potential energy at the top has to equal kinetic energy plus potential energy at the bottom. Okay, so looking back, kinetic energy at the top is 0, potential energy at the top is mgh, equals kinetic energy at the bottom is 1/2 mv squared, and potential energy at the bottom is 0. So this implies mgh equals 1/2 mv squared. Since there is mass on both sides, those get canceled. And what are we left with? If I do this carefully, what am I going to see? gh equals 1/2 v squared. And my question is asking me for a v, so I can take 2 to the other side, and that will be v squared, or v equals 2gh square root. Given the value of g, which is 9.8 for Earth, and if you give me a height, say, I don't know, 10 meters or something, all I have to do is plug it in and I can get the answer.